All right, in our first example, we're going to explore proportions that may be formed from parallel lines. So in triangle JLN, so that's the whole triangle JLN, if LN equals 9.6, what are LM and MN? Are the sides divided proportionally, and explain? So why don't we just start by labeling the triangle. So we were told that segment LN is 9.6. So LN is this whole segment right there. So we know that is 9.6. And we're being asked to find LM right here and MN. Are the sides divided proportionally, and explain? So here's what we're going to try to figure out is how our triangle JLN, the whole big triangle, and triangle KLM, the small one on the inside, related. Okay, so if we take a look at both triangles, we can see that they both share angle L. JLN, so angle L is part of that triangle, and KLM, angle L is also part of that triangle. So both triangles share angle L. And then because we have parallel lines right here, so KM is parallel to the base of our triangle, JN, and anytime you have parallel lines cut by a transversal, you get those angle relationships. Alternate interior angles, same side interior, same side exterior, corresponding. So because of those parallel lines, we can also state that angle LJN is congruent to angle LKM. And let me show you where those are. So LJN is this angle right here. That is congruent to LKM right there. Those are corresponding angles. They are in the same position. Here's your parallel lines cut by a transversal. Corresponding angles are in the same position. So let's write that in. We know those are congruent because of corresponding angles. So we just figured out that we have, I'm going to go ahead and mark angle L up here, congruent kind of to itself. Basically, L is in both triangles. We have two congruencies, two angle congruencies. So what that means is that we have similar triangles. So triangle JLN is similar to triangle KLM by our angle-angle similarity. All right. So now that we understand that we have similar triangles, we can find our side LM and MN. So anytime, just so you know, if you have a triangle and you have a parallel line, a line that's parallel to a side of your triangle, those two triangles formed will be similar. We just kind of proved why they're similar over here. So now let's go ahead and answer the question. I like to redraw triangles, so I'm going to draw the big triangle. Here is JLN. We know that JL is this whole side right here, 5 and 3, so we know that that is 8 units. And then LN they gave us was 9.6. And then our other triangle that is similar to this is KLN. And I am drawing them with all the corresponding parts lined up, so it's just easy to work with. In this triangle, we know that KL is 3. We don't know what LM is, so I'm going to go ahead and just call that X for right now. That's X. We can solve for LN by just setting up a proportion and cross multiplying. So we're going to find our corresponding sides. So 8 corresponds with 3, 9.6 corresponds with x. So our proportion is 8 over 3 equals 9.6 over x. Then we just cross multiply to solve. One cross product is 8 times x, which is 8x. We set that equal to the other cross product. 3 times 9.6 is 28.8. When you divide both sides by 8, you get x equal to 3.6. And we said that x was our side ln, which is one of the things we're looking for. So we just found that ln is equal to 3.6. We answered one of the questions, so nice job. All right, we also need to figure out what mn is. Well, mn is equal to this part right here. So all we have to do is take the whole side length of ln and subtract out lm, and that will leave us with what we're looking for. So the whole thing is 9.6. Let's subtract out that 3.6 that we just found. This is 3.6 if I label the picture. And we find that mn is equal to 6. Okay, so are the sides divided proportionally? Well, let's take a look at what the sides are now that we know everything. So 3.6 and this is 6. So we're going to compare our sides. So let's take a look at LK over KJ. So that's this one side. Was this split proportionally? So here's LK. We're going to put it over KJ. So we have 3 over 5, which gives us a 0.6. Now let's take a look at the other side. If we take LM and put it over MN, LM over MN. So LM is 3.6. MN is 6. We just figured out those two sides. When we divide that, we get 0.6. So what that means is that KM, this segment right here, divides LJ and LN proportionally. So that is what we are going to write in. So that parallel line, KM, divides the two sides of the triangle, so divides JL and LN proportionally. All right, so one of our theorems, the side splitter theorem, that's what we just did. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the two sides proportionally. So anytime you have a triangle with a parallel line, a line that's parallel to one of your sides, we get these segments. We're splitting the sides. It's a side splitter theorem. So now we have segment AM and segment MB. We have segment CN and segment ND. And so we can set up a proportion. This parallel line did split our sides proportionally. All right, we also have a triangle mid-segment theorem. This will sound a little bit familiar because you guys worked with this in the last unit. If a segment joins the midpoints of two sides of a triangle, so G and H are both midpoints, we can see we've got congruent segments on both sides, so that makes those midpoints. Then the segment is parallel to the third side and is half as long. So in the picture, what we're talking about here, we have a triangle, If a segment joins the midpoints of two sides, so G is a midpoint, H is a midpoint, a segment is joining those two midpoints. This segment will be parallel to the third side, and it also is going to be half as long as that third side.